Hi and welcome back to the lab. And today here on the bench we have really something exciting. So that here is the mcHF SDR radio. And this mcHF QRP radio is a radio kit which has been built from a radio amateur, and well, it all was working out very good. And so when he finished the build, he recognized that beside everything else, the transmitter was not really working, and he was not able to find the reason for it, and therefore he asked me if I could have a look on it. I mean, it is really the first time that I have seen this radio kit, so never heard about it before, but that does not mean anything. So let's see if we can discover what went wrong with the build, and if we are able to help to get it really working as it should. So let's go to the bench and let's check it out, shall we? Okay, and here we have our HF SDR receiver or transceiver. Okay, I have connected it so far. So with the kit comes this wall plug AC adapter, which is delivering 12 volt 1 amp. Well, for testing purposes that is not a good idea, so I have connected my power supply to have all the figures in view. And now let's see if it turns on. Let's see. Okay. So it seems so. Yeah, it is working. Well, I do not hear something. Well, not really. Okay, so it's the first time that I have seen it, so we discover it together. I mean, nice display. So let's see if we can put here a signal to the unit. Let's see. Okay, so it is working. I can move it here. So I have not really made me familiar with the use of it, and so yeah, we have a little bit try and error here. So how can I change that? Where can I change? So can I change the steps? Okay, for tests that might be fine. So let me set my service monitor to 28 100 megahertz, and let me connect the antenna, can't see it, to the radio. Okay, so that is what I have done now. So that is AF gain, but to be honest I do not hear anything. Okay, so let's change the mode to FM, because I've set it to FM just to get any reaction from it. Okay, something is happening over there. as you can see. Ah, okay, have a look. So we definitely have receive on the right frequency, so that is fine. The radio is obviously set to, can you read it, 5 watt output power. And now let me see what happens. Ah, okay. So what we can see is that the radio itself is obviously going into transmit, as you can hear, and I can hear that my service monitor is reacting somehow when I press the PTT, but it is not showing any output power. So what I see as well, that when I switch here to transmit, that we get a higher power draw, and yeah, no, I thought it was fluctuating a little bit, but it is obviously not. So something is happening here. Well, let me first connect the radio to my LP500 to see what the LP500 is showing. Okay, so on the radio I have the same setting, no changes, but now I have connected here my LP500, and now let's see if we get any reaction here. No, so the LP100 is definitely showing nothing at all. Okay, so we definitely do not see any output power on our LP500 or on our Roder and Schwarz service monitor, but that does not mean anything. I mean, there is no output power, but we are more interested if the radio basically works. And with basically, I mean if for instance our local oscillators are there, if maybe the pre-amplification might be okay, or basically what's about our frequency generation in general. So that is something we can see if we are not asking for such a high output power that our LP500 or our Roder and Schwarz is able to show anything, right? So that is now the point where we connect our spectrum analyzer to the radio to see what's going on. Okay, and here you see I have connected here my spectrum analyzer to our radio, but it is not directly connected to the radio. Be careful, you can really blow your front end of your spectrum analyzer. You always need to have an attenuator in between, so that is very important, otherwise you are going to kill your spectrum analyzer. Be careful. Okay, so here is our screen. So the important information is I've set, of course, the analyzer to 28.1 megahertz as center frequency, and of course the span is set to 10 kilohertz. Now let me push here our PTT so you can see it, and let's see if we see something. Oh wow, have a look. So we definitely have something, and now let's investigate that a little bit more. Okay, so let's press PTT once again. So there we have obviously a carrier, and I'm now interested if I put here a cursor to our peak. So I'm not sure if you really can read it, but here in the upper right corner we see that our marker is on 28.998 something megahertz, and we see that our signal here is minus 34.7 dBm, which could be a kind of driver signal, but it seems that the final stage is not really working. But it is definitely good that we have here a carrier, because that is telling me that quite a lot of functions and functions finally are working, and therefore that is first of all a very good sign, because now we have a point where we can start from. So therefore let's have a look into our block diagram, and as it is a kit, of course, we definitely get all the documentation, so you only need to search on the internet for mcHF QRP radio or radio kit, whatever, and you will get all the informations are necessary to do some services here to the radio. And well, so the important thing what we need to investigate is here the red pass, because the red pass is our TX pass, and you see that we have here our audio codexer, and the audio codex chip is giving out an IQ audio signal, and here we have a IQ to quad converter, and then we have a quad preamplifier, and then we have here a mixer, which is finally the mix signal, giving it over the bandpass filter to the power amplifier, which is or should deliver 10 watt output power through our low pass filter set out to the antenna and out to the air. And what we know so far, that we get here at our antenna output a signal, but the signal itself is quite low. So we have seen, what was it, minus 37 dBm, I believe, and that could be something which might be here in this area, and somewhere our signal get lost. So maybe there is something with our band pass filters which maybe switched completely off or on the wrong band, or our power amplifier itself could be defect, or it is something wrong here with our low pass filter. So that low pass filter, as we all know, is our transmit harmonic filter, which is very important, but maybe something is wrong here. So I believe we directly can start our troubleshooting at the output of our SN74 CBT 3253C, I believe. So that is the transmitter mixer, and I believe that we should find here our signal, and let's go from there. Okay, and of course our radio have some settings. So we have here a PA button, and when I transmit and I press this button, I see that our carrier is going down until it disappears completely, and then I see that it gets back. So that seems to be a kind of output adjustment. And yeah, you can see it over there. I haven't recognized it directly. So when I'm pressing here the PA button, you see that we can reduce you know, the output power, which is nice. And what have we seen? And full. So now we should see full output power, but in reality we see nothing on the spectrum analyzer. But when I go here to 5 watt, then I can see our minus 36 or 37 dBm. So, you know, that is working, and that is again a very good sign. And of course here are a bunch of settings where we could go through. So you see, I'm not sure how to operate it. Maybe that system previous, and how can I go? No, I'm not able to go down. Something is working here. Okay, I can go through the menu, as you can see, and there is a PA configuration where I can and what? TX power. Okay, so there I can configure a lot of things, and obviously I can also the filter selection can be performed. Though that is an SSB filter and such. So you see, we really have a bunch of functions, but I think it makes sense to look where we are losing our signal, and then it might be a good idea to go, if necessary, here again into our menu to then try to see if we can change settings in order to get you know, our wanted output signal. But therefore, of course, let's crack open here the radio, and let's have a look inside. As we discussed already, it is a kit, and we will see how the kit was built, and maybe that we find some problems with the build. So, well, it might be a surprise, so let's crack it open and see. To be honest, it is really a pain to get here the kit out of the housing. So yeah, it is not really service friendly. So it seems that everyone expect, if the radio is running, that you never need to get inside. Or maybe it is this housing. So it seems that there are different housings on the market. So for my point of view, this housing is not really the right one, since it simply do not want to let you in. So you really have to take it apart completely. Okay, so finally I have it apart. So that is the RF board, and this here is the controller board with the MCU on it, as you can see. So as far as I know, the kit comes populated with the most SMD parts, but still there is a lot to do, and I've already seen that here some cores have not been winded very well, so you can see it here, and as well here with our filter cores. Yeah, I don't know if our little RF transformers here winded in the right way, because that all is done by the person who builds this kit. So therefore it can become very easily to a rabbit hole, since you do not really know if everything has been done right here with the filters here and transformers in our RF stage. I think the best is to check it first under the microscope to get an impression if we see something obvious, and if not, I hope we are really able to test here on the board, because as you have seen it, it is connected here with this connector here, and when it is once connected, we do not get access here to the boards. So I would need to build an adapter that I can operate it apart from each other, that I have access to everything, and I do not really think that that is really worth all the work. Finally, it is a kit, and the purpose of a kit is that you should try to find your errors, and try to find over the web some hints where you need to look. But anyways, we are not here at the end, but there is definitely a point where I stop it, because it makes no sense to go ahead for me, not for anyone who is building this kit and is interested and willing to learn and understand how it hangs together. And yes, if there is something here in the RF part, of course you need some test equipment to get a clear picture of what's going on. But most of the time, and you all know it from the past with all the Heath kit sets, it is the same. The most problems with all the kits is that there are build failures, and I believe if you really build it as it is described, there's a very high chance that, you know, kits like this will work right from the beginning. So I still believe that there is somewhere, you know, a problem, an error, simply with the build. But anyways, let's go step by step. Let's observe this under the microscope, and let's see if we can see something obvious. Okay, so let's start here with our controller board, and yeah, so here are all the push buttons, of course, and well, you already see that we have here some weaknesses which should not be present on a board like this here, but well, on the other hand, we all have to learn. So up to now it is not that bad that it wouldn't work. I mean, sure, soldering needs to get improved here a little bit, but so that is nothing where you have to blame anybody. I mean, we all started at a point, right? And so I'm mainly interested here if I can find open connections or maybe shorts. So that is definitely important. For many of these connections here, it is definitely important to have not connections to ground, because the whole base, so the PCB base itself, is ground, and there's always only a little space around a connection, as you can see, which is not ground, because that is the connection. So therefore it is always difficult, right? So okay, here we have some issues with our electrolytic SMD caps here. Okay, but still okay, not a problem. So you see, this ICs obviously has been populated before, so that is from the vendor, and the rest, not sure if this components has been populated by the manufacturer or vendor or whoever. I mean, even this soldering is not 100% I would expect it, but well, it is okay. It is not too bad, but you know, it is not perfect either. Anyways, here, so that is our MCU. So there you can read the type. Okay. So what is with our crystal here? Seems to be solid. Fine. What has happened here to this? Well, I believe that this is not solid. That is not solid. Surely not. So that is already, yes it is, it's definitely, it's open here. You can definitely see it. Let's see if I can get it better in focus. Yeah, so we need to do this here for sure. Okay, so let me prepare soldering, my soldering equipment. Problem here is we have to clean the old problem, and then we can go ahead. Okay, so let's let me prepare everything we need. Yeah, okay, so first of course we have to clean it, so no doubt. And well, let's see how we can do it best. Okay, sounds good. Let's see. Yeah, so that was definitely no good connection for sure. And well, that then makes already no sense. Okay, I believe that this joint has a ground plane, and that might be the reason why it was so difficult. Okay, so let's try to get it better done here. Yeah, that is ground for sure. So here already you need the right equipment, otherwise you are lost. But I think that now it is already fine. Let's see if I'm right. So, by the way, if you are more interested by quick videos, then this one here is definitely not the right one for you. But there are many who are really interested in videos like this, and therefore we do it. And you see, even with good equipment, it is not easy, simply because we have too much, really too much ground plane, and therefore I do it for a second time here to be sure that this connection is given. Even I don't know what it does, but we need to be sure that it is good. Okay, once again. And if you have so much ground plane, you really need to let the material get hot in order that you get the needed connection. And you see that it is here not so easy, right? It is not easy. And therefore, sometimes, you know, an easy kit can be getting difficult. And that is something what obviously happens here. So all looked so easy, and then finally there is a problem, right? That is what we have here. But now it really looks solid. So let's test. Yes, solid. No problem. Now it is solid. Everything is okay. So that was definitely very first serious found here. And you still see that we have a lot of flux still around, but that is no problem. So we do not need to get it all away, so that is no problem at all. So let's go further with our searching here, because sure we need to go over the board very, very carefully. Okay. Okay. Seems to be okay. Now let me go through the other pins here. Yeah. What is here with this pin? Solid. So that might be already a little bit too much. But you know, the problem of course is I really cannot do everything here. Okay, so that is obviously okay. What's going on here? What is going on here? Let's double check. Not too bad. Okay. Once again, what do we have here? Here, this is good on the other connector, obviously. But what is here? Is that solid? No. don't believe that that is solid. So there is obviously a second joint which we need to rework. Well, the question is, makes it sense that you really go with me here through all this rework. So it really takes a while and it might get boring. So I think, yeah, let me do this one here, and then I stop until I have another serious finding. This one, of course, we need to do. This is ground as well, but not that difficult like our other one. That is much more easier. But as always, we see soldering definitely makes the difference, right? It definitely makes the difference. And without the right flux and without the right equipment, you are definitely lost. Okay, that's fine now. And these both are solid. Okay, so we are already on the RF or HF board, and we have here one of our HF transformer, and that is not a real finding, but I can tell you what really makes me nervous. So you see that the wiring here from this transformer here is really lying flat here on the board, whereby it should be done a little bit different, because we have here everywhere ground, and you see when we go here around this pad, right? Of course we have there where we need to get it connected, but on the other hand, you also see here that if you know the isolation, so the insulation of our wire here is broken, and it is here lying to the ground, there is a high chance that we get a short. So those connections should be done a little bit different. You always should try not to get the wiring here from our transformer in any way in contact with ground, except of course this one here. So of course this is connected to ground, as we all can see. And here, look, this transformer. So that is not a real found as well, but you see, oops, so picture is gone. Okay, here we are back. But you see that really the quality here is really bad here. And that is at the end really critical, right? So you really should improve your soldering skills before you start such projects here, because you easily can really destroy your whole kit. And yeah, That is really a shame, you know. So, but I think that is still good. The connections are solid, but still, you know, that makes me nervous. Look here. So this solder point here is very close here to ground. Okay, but finally it might be okay. Yeah, you see, that is what really happens with kids. Okay, and look here. So that is definitely something what makes me really nervous. So, wow, I'm not sure if we really have here solid connections. So let's test what we have here. Oh, look here on the right hand side. So that really does not look very promising. So let's see what we have here. Oh, look this here. Oh, here as well. No connection at all. Yeah, okay. I'm not sure if that is here the transmit-receive switching relay, but here we definitely have bad connections. What is here with the second one? So that seems to be a little bit better, but on the other hand, so the workmanship is still very poor, and I really do not wonder why we have here problems with transmit. And look here, this contact here is completely over our ground. And what is this? What is this? Let's see. Come on. Open. This is definitely open. Look here. Can you see it? Let's try to display it a little bit better, and you see how difficult it is. Let's see. Can I make it a little bit more visible? Let me see. Maybe a bit more light. And again. Yeah, so maybe now it is in focus, I believe. And look here. Can you see that? So that wire, I can push it through. So it definitely has no contact. Oh my goodness. Oh my goodness. So I literally need to check here all the solder work, which is, to be honest, no fun. Look here. Yeah, so we really can go through, and we can through, and we find more and more problems here. And yeah, so what can I do? What can I do? This connection is not good either. For sure not. It is not. It's the same problem. Look here. I can move it inside the solder joint, so not solid. And here, this one, I don't know. Tja. Tell me, what shall I do? I mean, the problem with kits is this kit never worked, and you know, so you have not a solid starting point. So it is a little, it is a little bit like somebody was already tinkering in a radio, and you don't know where the starting point is, and that is here exactly the same with the kit. Oh boy. Here again, so the wire here is really, can you see it? Where are we? Where are we? There we are. So have a look. So here again, we have the wire lying over to ground. I mean, of course, this PCB is with a solder mask, so our green solder mask, and that is of course a little bit isolation, of course. But have a look. This is really a problem. I mean, you see that the joint here is over, you know, our ground. And that should not happen when you are building a kit. And the flux which has been used here is really odd. It is not behaving like I would expect it, and I know it. It is really sticky and yeah, not normal. Finally, it is not normal. Here we have the same. So that could get an endless video. It could get an endless video. Oh my gosh. Yeah, so let's see what I can do here. Okay, so what you can see here, I have already cleaned here the pads a little bit. I know that is not perfect, but yeah, so that is the best I can do, and I try to adjust here a little bit the pins, and yeah, you see how badly they are not lined up with the pads on the board, and here of course we have the same situation, so that is not nice. But I think when I now reflow it, we may have a good chance that it will have, first of all, a good contact, and of course secondly that we do not have shorts to other pads or to ground or whatever. So that, I mean, is the only thing I can try. So I can, or I'm not willing to go with hot air to this relays, since you have different types on the market. Some can handle hot air without problems, and others are simply melting, and I do not try that out. So they have to be in like they are, very much unlined. But the most important point here is that we get a good connection. So that is definitely all I really want. So therefore, let's try how we can improve this situation here. I hope, yeah, that finally we can get it run. Yeah. Oh, no power here. What's going on? Of course, I need a hot solder iron, and I don't have. But we will be there, yeah. So now let's try what I can do here. Okay. Not too bad. And that one here. Yeah. I mean, of course, it is not perfect, but finally it is the best what we can do, and we go directly ahead here with our second relay. Let's see. Should be good, and we directly try. To clean it here a little bit. Let's see how it looks like. It is not perfect, but how could it be perfect under these preconditions? Yeah. Okay, let's do the other side. Let's do the other side. Okay, let's get in focus. Yeah, that looks good. Okay. Let's do some flex to the contacts, and then let's go over it. Always hoping the best. Always hoping the best. Yeah. So I try to bend while I'm soldering the pin a little bit to to get it here out of the way. Okay. And last one here. Let's see how that works out. Yeah, not too bad. Now let's go over here to the second one, and of course I try to bend the pin a little bit. Seems to be fine. I do here the same to get away from ground, and of course we do here the same. Okay, and here we do of course the same, which seems to be okay. Oh my gosh, yeah. That is something nobody can really pay. But it is something you should see, and maybe you can take one or the other hint how not to do those things here, right? Okay, but basically I would say looks good. Okay, let's check here. Not too bad. Okay. Well, and beside other issues I have already solved here on the board, we have here finally, so that is our mixer IC, and to our mixer, of course, we get the local oscillator frequency, then we get here the signal mixed, of course, and then here we, no, you can't see it, here we have a little RF transformer, so that is what it's coming out of our mixer IC, and then leaves this little transformer to the bandpass filter, not board, bandpass filter section, let me call it that way. So but what we already can see here again, and that again makes me very, very nervous. So let's see that you can see what I mean. Look here, so this transformer is soldered to the board or to the pads where it should be soldered to. It is not really in line, and we have here again the same problem we have seen on many different components, that finally, let me clean it a little bit, that finally the pad where we should have here our connection to is overlapping here to ground. I hope you can see it here, here in the middle as well. So here is the pad, right down here, so that is a pad, and then here in the middle that of course is ground, and you see the overlapping. So this transformer is not really lined out, and that is definitely again a serious issue. So in order to get here something out, let me call it that way, we definitely need this component more or less here on our pads and not overlapping to ground with the risk. And look, this blob here, so that is really a blob. So okay, let me try to improve it a little bit, but honestly I cannot put too much more into this project. I mean, we have already corrected a lot, and I'm still sure if the owner is going through this board very, very carefully and checks joint for joint, then I'm sure that he can improve it to a state where it will finally work. So I just do some more steps, but then, to be honest, I really have to stop. Okay, now let me try to improve this here. So let me show you this here, that you are able to see it better. Let's see where we have it more or less in focus, but I think you already can see what I meant. So look here. So it is more or less placed here over ground, and I mean, it is clear that there is a high risk, and even if it is only a little resistor which is here present to ground, that makes it nearly impossible that our circuit works. So the only thing what I can try is to get the coil out, this little transformer. I need to try to get it out and to really place it as it should. But then when we have done that, so I just want to remind you, it is a kit, and all these transformers here has been done by the guy who built it, and we do not know if the winding of this little transformer is correct. So if something is mixed here on this transformer, it will never work, never ever. So therefore you see what it means. Okay, so I was able to get here our transformer off, and what I really want to show you as well. So you see here is definitely a lot of old flux on the board. So I only can recommend, whenever you do projects like this, I mean, so we all know we need flux, so that is definitely essential, no doubt. But what you always should do, and you always see me doing it, when I have finished a solder work, I directly go and clean the pads. So that is definitely essential, okay? And now you see it already looks much better here. And now I try to replace the transformer, and yeah, the pain is here that yeah, maybe it might work. I thought that the pins were bended more, but finally we really can be lucky that we can get it in quite nicely. Okay, so let me try to show what I'm doing in cases like this, and I try to show it right from the beginning. Even we have here definitely you know, a problem, so we still have the little leads bent a bit, but anyways, let me try to show you how you can manage those things. Okay, let me switch on here my fume extractor, and in this case I put here a little, as you can see, a little solder to the pad, right? Then I grab this little transformer. Yeah, the transformer is sticky, so I can't get it to my tweezers. Okay, so that should work. Now you put it to the board so that you really have contact to the board, okay? Then you melt the joint, the solder joint, that you get this really to the board. And you still see that we have a little issue here with the bended leads. Now we put some more flux to the board. Okay, and now we try to get it done. So we really must be very careful not to have finally too much solder here to our pad. And I do not know if you see that there are dark spots here, and that is simply because it is difficult to get the board after something like this here completely clean. So that is very difficult if you once have the situation we have here. Okay, so let me see if I can bend this while I'm soldering. That seems to be not too bad. That is ground here. I directly recognize it. Okay, once again, let me check how it is here. And maybe let me try to get it even a little bit better, just a little bit. And by the way, what you can see, if you do not directly remove the flux, you have problems to get it off afterwards. So you always should clean it after you have soldered it to the board. So let's see. And I believe under the circumstances we are working here on this. Now you clearly can see, and let me zoom in here, that you are able to see it entirely here. I think so. We have it in focus, and now you see. Now we really see that our transformer is on the pads correctly on both sides. So that is still a little bit flux, which is sometimes difficult to get off. So therefore not only Q-tips are needed, sometimes you need to brush it off a little bit, like so. And but still, you see, still there is a little bit on the board, but it is very, very helpful to try to clean the situation as much as possible. And I hope you see what the difference is here. So I think it is a 100% improvement. And really, what gives me headaches additional, so because we have to suspect that we had shorts, some here on the board, that most likely some of our components are already burned. And I have found here, let me see if I can show it. So let me go here into focus. So look here. So we have here a resistor. It is, as far as I remember, a 100 ohm resistor. And it is on parallel to a coil, so we cannot directly test this resistor, but by the look of it, so you see here our surface, so you see that something cracked here, and yeah, that is definitely here my my fears that we have already burned components simply because we have too much problems here on the board, which makes everything really difficult. So yeah, I hope you see what I mean, and I really do this and I go forward and forward because I really want to show you what you need to know. Because if you don't understand the faults which has happened, then you never will be able to get it any better, because you do not have a good reference. And look here, so that here is another example. So that is the same issue. So the solder blobs are much too big, so we still have our old flux here on the board. You see it here, and we cannot say for 100% if everything is fine, or is here already another problem. And that is really frustrating. So I really would like to help the person who built it. I know, he is, I guess I already told it, so he is on a university, and he is studying electronics, and of course, I mean, we all have to learn and had to learn, and I did my mistakes as well when I started off with electronics. So that is nothing where anybody have to blame anybody. But what I can do, so my contribution to this is to show you on this example. And once again, it is not to blame the person who built this, right? It is not to blame him, definitely not. It is to show on a real good example where the problems are. And I believe, here, look, so this wire is not really in, so that is, so this wire is not connected here to the joint. So that means that here is definitely another error. And yeah, it is really a kind of sad, because basically this is quite a nice radio, and I really can recommend to anybody who want to start into electronics. We all, and I repeat myself again and again, we all had to learn. So nothing wrong with it, but try to get some old boards and try soldering on old boards, and then if you have a little bit more self-confidence, then you can start here with projects like this. And here, you know, I see that there is still the lecture. Do not really know how to pronounce it, but I believe you know what I mean. So you should try, before you start soldering these transformers, you need to get off here the lecture. I know it is definitely wrong pronounced. Sorry for that, guys, but I believe you know what I mean. So that is now the other side here of our PCB, and the little coil or transformer, not sure what it is. It must be a transformer. It's a transformer, of course. And you see that obviously it has not burned off here the lecture before he tried to solder it in. I mean, you can, before you put such transformers in, try to tin the leads, and the lecture here will burn off, so no problem. But you should not put it in without having tinned the leads, because then you are getting in this position where you try to solder it to the PCB, and finally you recognize that you have no contact, and your board, your circuit, whatever you build, will not work. So I will rework this as well. So I do the same what I've done with the other coil. I just simply try to take here the old solder off and do some fresh on it in order to get a good connection. Okay, so I have put it together for testing. We have really fixed a lot of bad solder joints, but there are still some which definitely needs to get revised for sure. But I just wanted to see if we have a kind of life. So, okay, let me switch it on. Okay, so it's starting up, as we can see. And we do receive. Of course, I've set it to FM. It's easier, simply easier. You know that I'm doing it more or less with all units, just to get a point from where we can finally go ahead. Okay, let me go over to the tester. Okay, and we can hear in the background that we have received. Now let's see if we get something out of it. Oh wow, 1.3 watt. So something is definitely working here, but still it is definitely not okay. But I just wanted to see if we can get out something, and yes, as we have seen it, we do get out something. I mean, it is still not very much satisfying because there are still problems here on the board. But I mean, finally having nothing, we have at least 1 up to 2 watt, it depends. So that means we are definitely on the right path, and that is telling us that there have been, on one hand, a lot of bad solder joints, and on the other hand there is definitely a lot to do. So I stop the video here. For me it was important to show a little bit what can go wrong and where you need to look for if you're doing those kits. This radio goes now back to its owner with my recommendation to really rework every single solder joints very, very carefully, going step by step, using the right solder one hand, and on the other hand a good flux and the right equipment. So minimum a very, very good solder iron with enough power to be able to really do this job. And that is everything I can do so far. We have proven that we can get out power, and yeah, as I said, that shows how it can be managed, even it is in that bad condition. Okay, so as I already said, stop the video here. Hope you learned something, and that is all what I wanted to show you. Bye.